Every day, we throw away things like food wrappers, plastic, and packaging. And we've developed tools and processes to help us dispose of this trash properly. Off Earth, it's a different story. Without waste management systems in space, even everyday items can become big problems. As we prepare to return astronauts to the moon and eventually onto Mars, one thing is certain: garbage is inevitable, and how we handle it matters. But waste is only waste if it is wasted. On the moon, resources are limited. That means astronauts must make the most of everything they bring, even their garbage. In space, trash isn't just waste, it's potential. Imagine an astronaut crew having dinner in a habitat. After the meal, there's now a pile of empty pouches and wrappers headed for the trash. But what if those could be melted down and 3D printed into small tools or components? Or imagine that crew disassembling hardware after landing. What if the leftover brackets and composite panels could be reassembled into a lunar workstation, shelves, or even a rover attachment? And when astronauts change clothes after a long spacewalk, that creates fabric waste. But maybe those old shirts could become insulation panels for a lunar habitat. And the list goes on, from transportation supplies to foam packaging to cargo bags. The possibilities for what to do with them are limitless. But we need your ideas. NASA is calling on inventors, entrepreneurs, researchers, and visionaries from around the globe to join our LunaRecycle Challenge. The mission? Develop energy-efficient, low-mass, and low-impact recycling solutions to transform non-metabolic space trash into usable products to support off-planet science and exploration. Teams who enter the challenge will compete for a chance to win cash prizes. Your ideas could be put into action now as we prepare to return to the moon and beyond.
Hello, and welcome to NASA's LunaRecycle Challenge winners announcement. I'm your host, Savannah Bullard, and today we will be announcing the winners of our challenge that innovates trash management and recycling systems for space exploration missions. The idea behind NASA's LunaRecycle Challenge came from the realization that an astronaut generates roughly 125 kilograms of non metabolic waste in a single month. Non metabolic waste refers to what we'd consider trash. Think food wrappers, clothing, plastics, metals, and the like. So that's nearly 300 pounds of disposable refuse, all from one person. Managing these outputs is critical. Everything we bring with us to the moon and Mars missions need to be valuable beyond its initial use. This allows us to be more strategic and efficient when planning for long duration missions, and there's the added benefit of creating a clean and tidy space environment. Today, we'll be hearing from different subject matter experts from the challenge to talk about why this is so important. And we will announce the Phase 1 US and international winners for both the prototype build and digital twin tracks. To kick us off, I would like to introduce Dr. Rajiv Doraswamy. Rajiv is the Director of Space Technologies and Engineering Research for the College of Engineering at the University of Alabama in Tuscaloosa. Thank you for being here.
Thanks, Savannah. Thanks. I'm really enjoying being here and talking to you today. It's a beautiful day on campus and a great day to announce our winners.
I bet. So, Rajiv, UA has been the allied partner for this challenge since it opened in 2024. Tell me about the partnership and what we've been able to achieve through working together.
Sure. This is UA's first real strategic partnership with the University of Alabama and NASA. Although we have worked with NASA since the inception of the space program, this challenge gives us the opportunity not only to interact with teams from the United States, but all over the world. We're getting a chance to work with inventors, creators, and thinkers from all across the globe, and allowing our subject matter experts and faculty to really expand their reach, which is really the core of the university's mission.
Wonderful. What an
NASA has been
excellent.
a fantastic partner and really looking forward to phase two.
We are too, and we're so glad to be able to work with you in phase 2 as well. I understand the reception for this challenge was pretty received well, too. Is that right?
It's been fantastic, Savannah. We had over 1,200 registrants from 46 states and over 80 countries, and the judges had their work cut out for them. We had 200 plus viable submissions, and the judges had to work to get that down to our 13 winners and 4 recognized international teams. It's been a lot of work for them, and they've done a fantastic job.
Wow. And I understand that is record breaking for Centennial Challenges to have that well of a reception in a first phase.
It
So
is, and
I know
we're really excited about it.
We definitely are too. And thank you for this partnership and for allowing us to get here. And I know you can't disclose much yet, but what are you most looking forward to in phase two?
Well, Savannah, as I looked through the entrance, every time I kept saying to myself, wow, this is a great idea, or wow, I didn't think of that, or wow, I'd really like to see this in action. So we're really looking forward to seeing these fantastic ideas, both on the digital twin and the prototype build side, actually developed into real products. So that's going to be really fantastic, not just for us here at UA, but also the community at large. We're really looking forward to welcoming these teams to campus and allowing them an opportunity to show off what they can do and a time to really interact face to face with our students and our faculty.
Wonderful. Well, I'm certainly excited for it and cannot wait for what's to come. Thank you so much for being with us today, Rajiv.
Thanks again, Savannah.
Of course, now we're going to chat with another member of our team in just a second. But if you're just tuning in, we are announcing the winners of NASA's LunaRecycle Challenge today. This challenge aims to help astronauts make the most out of non metabolic, recyclable items while on long duration missions to the moon, Mars, and beyond. I'm joined now by Jera Mater, the program executive for NASA's Prizes, Challenges, and Crowdsourcing program, which manages NASA Centennial Challenges as part of the agency's Space Technology Mission Directorate. Jera, thank you for being here.
Thank you so much, Savannah. It is such a pleasure to be here today with University of Alabama and all of you. We're so excited to reveal the winners of phase one and to essentially prepare us for the next phase of the competition. It's great to be here.
Absolutely. Thank you so much for taking time. Now, I understand your experiences in competition and prizes, but this is your first Centennial Challenge in this role. And for us, the first Centennial Challenge that's featured digital twins. Can you give us a brief overview of what a digital twin is and what you saw from our participants in this track?
Yeah, absolutely, Savannah. So, a digital twin is a high tech virtual model that mirrors a real world behavior of a physical system. So, digital twins can use data, physics, and domain expertise to simulate how it performs, reacts, and evolves over time. And at NASA, we use digital twins to help us with a lot of things to help predict outcomes when experimenting. And this saves us time and resources while we're making strategic decisions going forward. And in this competition, the digital twin track, it invited really a diversity of solvers, the likes of which we haven't seen before in our Centennial Challenges. And we're really, energized by what we saw. And we saw that their submissions gave us a deeper understanding and insight into how they would perform since they have that simulation technology to support their hypotheses. And I believe digital twins have really a tremendous potential to help NASA further its space exploration goals and mission, really in an efficient and strategic way going forward.
Wow, that is so innovative, perfect for our program. And I understand digital twins also had their start at NASA Marshall Space Flight Center with John Vickers. And so fantastic to have subject matter experts like him on the team. I'm ready to hear who won, so go ahead and take it away.
Absolutely. All right. In the digital twin competition track, each earning a monetary prize, the US winners are Acme Space. Acme Space implemented Luniform, a dual chamber system that recycles Zotec F30 foam into modular lunar building panels with 99% material efficiency and no chemicals or water. Sysloon used a VR enabled digital twin to simulate and optimize robotic lunar recycling, turning waste into valuable materials for sustainable space missions. Gensler Advanced Concepts designed a closed loop lunar recycling system that transforms waste into vital resources, advancing sustainability in space and on Earth. Prime developed a recycling system that uses vacuum and cryogenic conditions with 3D printing integration and minimal water for efficient material separation in space. And rounding out with TerraSynth. TerraSynth created the Lunar Reforge System, a compact automated solution that turns food packaging waste into 3D printing feedstock for on-demand manufacturing in space. In the digital twin competition track, earning recognition from NASA, We had one international winner. Esperanza. Esperanza built a digital twin of a lunar recycling system that uses Apollo regolith data and mining principles to boost resource recovery and cut waste.
Fantastic. Congratulations to all of our digital twin winners. And thank you so much for joining me, Jara, and for doing the honors of announcing those prizes.
Thanks, Savannah. It was my privilege.
Well, next up, we're going to meet a very important member of the Centennial Challenges team. If you're just tuning in, we are announcing the winners of NASA's LunaRecycle Challenge. This challenge promotes the development of recycling systems for non-metabolic waste streams. This includes items like food packaging, metals, plastics, clothing, and other items that are typically used and then thrown away. This challenge is critical for long-duration space exploration because we need to ensure that astronauts can make use of everything they bring with them when they're traveling further and longer than any human has gone before. Now, last but certainly not least, I'm joined by Dr. Jennifer Edmondson, the program manager for NASA's Centennial Challenges Program Office here at Marshall Space Flight Center in Huntsville, Alabama. Jennifer's expertise is in geology and in-space manufacturing, so discussing the prototype build track seemed like an apt pairing. So thank you for being here.
Thank you so much for having me here. I'm so excited to help announce these winners.
Of course. Now, prototype builds are pretty par for the course for Centennial Challenges. Tell me about the team, what our team was looking for with respect to this competition.
So the subject matter experts were looking for prototype ideas that would easily integrate into crewed missions to the moon. And the prototypes would recycle items that are commonly found in space missions like bubble wrap and food packaging. And we had so many good ideas submitted to the competition, and I know it was a difficult decision for our 50 judges to make, and they discussed all the submissions at length to determine the most promising technologies for awards. So congratulations in advance to all of our winners.
Love it. And I'm just so glad that we received such an impressive candidate pool, a record for Centennial Challenges, and that just makes me so excited for phase 2. But first, drum roll, let's hear our prototype winners.
In the prototype build competition track, each earning a monetary prize, the U.S. winners are in alphabetical order: Acme Space recycled Zotec F-30 foam into modular building blocks for lunar construction. Cerberus designed a system that transforms Zotec F-30 and regolith into composite materials and aluminum parts for lunar construction and manufacturing. Cisloon built meltdown extruder hardware that recycles lunar waste into containers, enabling near-zero waste missions. Lunar Nanomand used advanced additive manufacturing and microreactor technology to turn lunar waste into useful products during missions. MoonMade invented a technology that turns bulk thermoplastic waste into fabrics for astronaut gear and lunar construction. Phoenix Loom worked on an automated system to recycle nearly all cotton and cellulose fabrics in space and low-gravity environments. Plastronauts proposed using microwave-assisted decomposition to turn mixed waste into gases for air and solids for building on the moon. And finally, LunaRecycle Innovations created a dual-stream system that recycles Nomex and nylon into durable 3D printing filament for lunar infrastructure. In the prototype build competition track, each earning recognition from NASA, the international winners are in alphabetical order. DOPS Goes Lunar developed a reclaim kit that converts residual lunar materials into new products and feedstock. NBrains implemented a system that recycles low-density polyethylene and nitrile gloves into high-quality 3D printing filament for lunar missions. And finally, Waste Parrot automated a lunar recycling platform using AI, robotics, and 3D printing to turn inorganic waste into sustainable materials.
Congratulations to all our prototype build winners. Thank you so much for joining me, Jennifer, and for doing the honors of announcing those prizes. I'm looking
Thank
forward
you
to
so
what we
much.
get in phase 2.
I am as well. Thank you so much.
Of course. And thank you to all of our viewers for watching. To stay up to date on the LunaRecycle Challenge, you can visit nasa.gov/LunaRecycle and follow NASA Technology on Facebook and X. On X, that's NASA_technology. We'll be announcing more information in regards to phase 2 later this summer. And to stay in the loop, bookmark our website and sign up for the challenge's email newsletter at lunarecycle.ua.edu. Once again, congratulations to all of the winners of NASA's LunaRecycle Challenge Phase 1. Thank you for watching.
NASA proudly announces the winners of the LunaRecycle Challenge Phase 1. In the U.S. Digital Twin Phase 1 category, the winners are Acme Space, for implementing Lunaform, a dual-chamber system that recycles SOTEC F30 foam into modular lunar building panels with 99% material efficiency and no chemicals or water. Sysloom, for their use of a VR-enabled digital twin to simulate and optimize robotic lunar recycling, turning waste into valuable materials for sustainable space missions. Gensler Advanced Concepts, for designing a closed-loop lunar recycling system that transforms waste into vital resources, advancing sustainability in space and on Earth. Prime, for developing a recycling system that uses vacuum and cryogenic conditions with 3D printing integration and minimal water for efficient material separation in space. Terrasynth, for creating the Lunar Reforge system, a compact automated solution that turns food packaging waste into 3D printing feedstock for on-demand manufacturing in space. In the International Digital Twin Phase 1 category, the winner is Esperanza, for building a digital twin of a lunar recycling system that uses Apollo regolith data and mining principles to boost resource recovery and cut waste. In the US Prototype Build Phase 1 category, the winners are Acme Space, for recycling SOTEC F30 foam into modular building blocks for lunar construction. Cerberus, for designing a system that transforms SOTEC F30 and regolith into composite materials and aluminum parts for lunar construction and manufacturing. Sysloom, for building meltdown extruder hardware that recycles lunar waste into containers, enabling near-zero waste missions. Lunar Nanoman, for their use of advanced additive manufacturing and microreactor technology to turn lunar waste into useful products during missions. Moonmaid, for their technology that turns bulk thermoplastic waste into fabrics for astronaut gear and lunar construction. Phoenix Loom, for their work on an automated system to recycle nearly all cotton and cellulose fabrics in space and low-gravity environments. Plastronauts, for their proposal of using microwave-assisted decomposition to turn mixed waste into gases for air and solids for building on the moon. SelenoCycle Innovations, for creating a dual-stream system that recycles Nomex and nylon into durable 3D printing filament for lunar infrastructure. In the International Prototype Build Phase 1 category, the winners are DOPS Goes Lunar, for creating a reclaim kit that converts residual lunar materials into new products and feedstock. And Brains, for their system that recycles low-density polyethylene and nitrile gloves into high-quality 3D printing filament for lunar missions. And Waste Parrot, for their automated lunar recycling platform using AI, robotics, and 3D printing to turn inorganic waste into sustainable materials. Congratulations to all the winners. Learn more about NASA's LunaRecycle Challenge at nasa.gov/LunaRecycle.